Welcome back, Physical Science 20. This is the section 7.2, Mass Relationships in Chemical Equations in the FC3 section. So with this one, we'll be looking at mass questions. So the beginning of the booklet you have here starts off with astronauts being out in space. The biggest problem here is how, when you're constantly breathing in oxygen, expelling CO2, how do you get rid of the CO2? In a spacecraft. So it talks about air scrubbing technology, which causes CO2 to be used up by combining it with lithium hydroxide. And as a result, lithium carbonate is formed and water, which of course wouldn't be that very harmful. So they talk that's one possible way you can eliminate CO2, and then the key role here is to figure out how much lithium hydroxide you would need out in space, let's just say, to get rid of all of the CO2 that a human being could possibly expel. So that leads into masses and chemical equations. So over here we can see that 1 mole of CO2 requires 2 moles of lithium hydroxide. So that is referred to as a mole ratio. These values give the relative amounts of one chemical required to completely react with another. So it's almost like a recipe. 1 mole of carbon dioxide requires 2 moles of lithium hydroxide. And of course it could also help predict the amount of product expected. So as a result, 1 mole of lithium carbonate is formed for every 2 moles of water. Okay, so with that, we'll look over here at this first question. Now I apologize, I should have done this on a separate page, but I kind of worked it up over here. So here, a typical astronaut exhales 8.80 times 10 to the 2 grams of carbon dioxide, or 880 grams of carbon dioxide daily. Determine the mass of lithium hydroxide you would require to react with that mass of CO2 and convert it into lithium carbonate and water. Okay, so we know how many grams of CO2. The trick is to find out how many grams of lithium hydroxide there is. Okay, and they kind of, in this example here, they kind of go through a long process here, identifying every single step. I would like to treat it though in just one big step, as you see up here. Before we get that though, working with this equation, what's really a good idea is to write what you're given in the question. If it's grams, write it underneath the compounds in the equation. If you were given moles, I tend to write that above, and you'll see why. Just because it's a nice schematic here when going from one compound to another. So we were given 880 grams of carbon dioxide, so I write that underneath the CO2. And the question is, how many grams of lithium hydroxide? So I write grams here. Now, in order to use the mole ratio in the equation, because we know it's a 1:2 ratio, we have to convert grams into moles, and then we'll be able to use the mole ratio, and then once we do that, go from moles back to grams. Okay, so if we set it up like that, so we can see it's 1, 2, 3 steps. Okay, and so if I start that out, the first step is a gram to mole conversion, so a molar mass conversion. So if you look up the molar mass of carbon and oxygen, you can figure out CO2, 1 carbon, 2 oxygens, it's 44.01 grams per mole. If we arrange it like that, grams will cancel, and I'm left with moles of CO2, which would be right here. So of course, we need to figure out how many moles of lithium hydroxide to get closer to the answer to the question. It's a 1:2 ratio. So 1 on the bottom, where we're starting from, 2 on top, that's where we're going to. That's the mole ratio. CO2, moles of CO2 cancels with moles of CO2, leaving up with moles of lithium hydroxide. So the last step will be to go from moles to grams. Again, we'll have to figure out the molar mass, this time of lithium hydroxide. 1 lithium, 1 oxygen, 1 hydrogen. If you've determined that, it's 23.95 grams for every mole. So we set it up like that. Moles and moles cancel, and if I multiply all the tops, 880 times 1 times 2 times 23.95 divided by 44.01, 958 grams of lithium hydroxide. 3 sig figs, 3 sig figs. or you may have left it in scientific notation just like here, 9.58 times 10 to the 2. Okay, so you can see it's a 3-step process for starting with grams and finding grams of something else. To use that mole ratio, we have to convert to moles. I believe there is a part B here. Oh, I guess there wasn't a part B. Yeah, so there you have it. So key steps here, put stars beside this. Convert the given mass to moles, because that's what they mean by amounts here. Apply the mole ratio of the two substances in the given question to predict the required mole of the other substance. Then convert that moles that you have back into mass. Okay, so we have another question here. They go through it, but I'm going to jump to the practice question here. A typical antacid tablet contains 0.50 grams of calcium carbonate. The chemical equation for neutralization of hydrochloric acid with calcium carbonate is given here. And the question is, what mass of hydrochloric acid will you require to neutralize the calcium carbonate? And then predict the mass of calcium chloride produced. So if we take a look here, I kind of wrote them schematic here like I did before. 0.5 grams of calcium carbonate. So that's what we're given. So I'll write it underneath the calcium carbonate. And then on the flip side, it's asking for how many grams of hydrochloric acid is required to neutralize. So you can see 3 steps. We need to change it to moles, then use the mole ratio to go from moles of calcium carbonate to moles of hydrochloric acid, and then lastly figure out the grams of hydrochloric acid. Okay, so you can see I'm going to have to know the molar mass of calcium carbonate and the molar mass of hydrochloric acid. So I worked that out over here. 1 calcium, 1 carbon, 3 oxygens. That works out to be 100.09 grams per mole. And the molar mass of hydrochloric acid, 1 hydrogen plus 1 chloride, is 36.46 grams per mole. So if I look at the steps here, what I'm going to be doing, first step is go from grams to moles, so 0.50 grams. Use the molar mass to go from grams to moles. Grams cancel and I'm left with moles, just like here. Now I need to go from moles of one substance to moles of another. It's a 1 mole to 2 mole ratio. 1 mole on the bottom, 2 moles on top, as you can see here. So if I was to stop the question here, I would end up with moles of HCl. But I want to go one more step, changing the grams. 1 mole is 36.46 grams of HCl. So in the course you can see everything cancels out nicely. I'm left with grams of HCl, and in particular 0.36 grams of hydrochloric acid. Okay, and part 2 of the question is what mass of calcium chloride is produced. So if you take a look over there, starting off with the 0.50 grams of calcium carbonate, change it to moles, go from moles to moles, and then to grams again. So it's a very similar process. I didn't work it out because I think you should likely try to determine it, do the same type of step, except instead of going from calcium carbonate to hydrochloric acid, we're going from calcium carbonate to calcium chloride. So at the end of this video, I'm going to get you to try that, and as you can see here, the answer should be 0.55, so hopefully you get that. And then number 2, I'm going to recommend that you do this one as well. The chemical equation for the complete combustion of propane is given as follows. What mass of oxygen is required to burn 8.8 kilograms of propane? And of course, kilograms, 1 kilogram is 1,000 grams, so 8.8 kilograms is the same thing as 8,800 grams. And then predict, once you do that, predict the mass of carbon dioxide produced. So we could go from our 8,800 grams of propane and figure out how many grams of carbon dioxide. So here you see the answers. Here they are in kilograms, or if you want to leave them in grams, that would likely be better. So I'm going to get you to try those questions, and then you can come back to see the final part of this video. Okay, see you soon.